Hey guys, so far you have learned 5 triangle congruence shortcuts. They're pictured here just to quickly go over them. We have side angle side with the included angle between the two sides. We have side 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 with all 3 sides congruent. We have HL for right triangles only, where the hypotenuse and pair of legs are congruent along with the fact that they're right triangles. We have ASA with the included side between 2 pairs of congruent angles, and finally AAS where the pair of sides is not included. Okay, so today we're going to talk about something called CPCTC. Before I even tell you what that stands for, let's just talk about what it actually means. So let's say that you proved 2 triangles congruent using one of these shortcuts. Let's just take one, for example. Let's say that we were using the side angle side. So if you did this, if you're using that shortcut and you proved 2 triangles congruent, once you had those 2 triangles congruent by the SAS shortcut, you would then know, of course, that the whole triangle is congruent, that all 6 of the parts are congruent. So if we used SAS to get the triangles congruent, we could then say, well, BC is also congruent to EF, and angle B is also congruent to angle E. Sorry, those marks aren't looking very good on here. And angle C is also congruent to angle F. And the reason we know that is because if the whole triangle is congruent using the shortcut, then all of its corresponding parts must also be congruent. So let's look at this title. CPCTC stands for Corresponding Parts of Congruent Triangles are Congruent. So once you've proven 2 triangles are congruent, you can then know that all of its parts are congruent. This is useful if you've used a shortcut to prove 2 triangles congruent and you only had 3 pairs of your 3 parts. Well, then all the other parts are also congruent. We're going to write it down on the next page. Okay, so let's write down those words that we just said. So CPCTC stands for Corresponding Parts. And then there's an of there. We don't, that's not one of the words, but there's an of in there. Corresponding parts of congruent triangles and then we stick the little word are, and then finally congruent. When you write this in a proof, you can just write CPCTC, but you still have to know what it stands for. So there very well could be a quiz question that just says, what does CPCTC stand for? And you'll have to write it out. So in a proof, I don't mind using the shortcut, but you have to know what the letters stand for. Let's write them one more time down here where these arrows are, and we can use some symbols and shortcuts here. And so for the first one, we've got to write out corresponding. There's no other way to write that word. Corresponding and parts. But then for congruent, we can just use the symbol. And for T, we could say the triangle symbol and then the congruent symbol again. So corresponding parts of congruent triangles are congruent. All right, so let's look at an example of a proof where we would actually use this. So this is a different kind of a proof that we haven't done yet. This is called a flowchart proof rather than a 2-column proof. I don't know if we're going to do any this year, but I thought it would still be good to introduce you to one and show you one. But here in this proof, the givens are that AD is congruent to CD, and that's marked in the diagram, and AB is congruent to CB, and that's also marked in the diagram. And you can see those right here at the kind of the first row of our flowchart proof. And then what we didn't have given, but we can get it from the diagram, is that this side is equal to itself by the reflexive property. So right here, we have our 3 parts. We have a pair of sides, and another pair of sides. And so we concluded then that the 2 triangles are congruent by side, side, side. I should have noted earlier, like what we're trying to prove in this proof. We're trying to prove not that triangles are congruent. We're trying to prove that 2 angles are congruent. And so we had to get the 2 triangles congruent first in our proof by using side, side, side. But then we can go one step further to say, well, if the 2 triangles are congruent, well, therefore, angle A must be congruent to angle C because of CPCTC. So it's often the last step in a proof when you're trying to prove a pair of sides or a pair of angles congruent. Just remember, you have to prove triangles congruent before you can use CPCTC. So it always has to come after a step where you're proving them congruent using one of the shortcuts. Here is another example, and I wanted to just walk through this one. It's already done for you. You're going to try your own in a little bit. But here is an example where we're given that WZ bisects angle TWV. Let's go ahead and mark that. So WZ bisects it. So that is congruent to that because it's bisecting the angle. They're also telling us that WT is congruent to WV. So that's congruent. And our goal is to prove that TZ is congruent to VZ, and we're trying to get there. So in the proof, you can see that the given statements are right here. WZ bisects angle TWV. And here's an example of a proof that's done where they split up the givens. You don't have to always put the givens at the beginning. You could split them up, like use this one given, and then what can I get from that? And then use another given, and what can you get from that? So from the fact that WZ bisects TWV, we then know that these angles are congruent, that angle TWZ is congruent to VWZ. Those are the ones we already marked earlier. We had marked them earlier in the green. We're just putting it into our proof now, and the reason for that is definition of angle bisector. And then, of course, the next given was that WT is congruent to WV. So there's our next given. And that's a pair of sides. So here we have, let's just mark that. We've got a pair of sides, and earlier we had a pair of angles. And then we can show that WZ is congruent to itself. And that's, of course, the reflexive property. And then that's a pair of sides. So now we have our three parts, and we can show that triangle TWZ is congruent to VWC using SAS. Side angle side, we have the included angle in between two pairs of congruent sides. And then finally, we can state that TZ, this is actually a mistake right there. That should say that TZ is congruent to VZ. So let's fix that. This should say VZ. That's what they were trying to get us to do. And the reason here is CPCTC. So once you get the triangles congruent, you use the triangle shortcut, then you use CPCTC to get one pair of sides or angles.